Hello, and thanks for joining us for another video from the Bismarck Weather Education Center. Please enjoy part 5 of our air pressure experiment video series.
Hi, and welcome to our experiment on surface tension. And if you've ever seen around a pond or you've been fishing at one point and you ever see an insect walk along the water without sinking, that is surface tension. And liquids such as water, and especially mercury, we're not going to mess around with mercury because it's poisonous, but we'll stick with water. Water is formed with a water molecule, of course, H2O, with the two hydrogen atoms being positive and the oxygen being negative. Now, when you have a depth of water, the negative side of the hydrogen molecule and the positive side, there's a lot of connections in a depth of water that these forces attract each other, and they all balance out. But what happens is at the very top of the water layer, where below it, it's interacting with the rest of the water molecules, but above it, there's no water molecules because it's just air. So there's this imbalance. We've been talking about an imbalance with air pressure. There's an imbalance with the water molecule itself. So what happens is there's this very strong molecular force that serves at the top of the water layer that comes together, and it forms a very, very strong membrane that allows the insect to walk across. That is called surface tension. Okay? So what we're going to take a look at how the surface tension behaves with a mason jar. And you can buy these in your local grocery store. And this is interesting because we're going to look at the force of air pressure, and then we have a neat little trick to show you with the surface tension. So what you do, you get your mason jar. And before we actually put the water in the mason jar, I do want to mention that in weather, when you look at a raindrop and it's round or spherical, that is surface tension because the top of the raindrop is in contact with the air above it, so there's an imbalance. So the cohesive forces for the water molecule at the very top try to direct the force into the center of the water droplet, and that's why you get the round texture or the round shape, spherical shape of a raindrop. Okay, let's go ahead and fill the mason jar up about 3/4 of the way full. And now we'll get our handy dandy paper plate, and we'll let the air pressure do its trick. The paper plate should stay on, which it does. That's good. Now we're going to remove the paper plate, and notice that the water stays in. Okay? Now just to show you this is no trick, we have a toothpick here. And I'm going to put this into the opening of this mason jar. And there it goes. The reason why it floats up because it's less dense than the water, so it floats to the top. Now, I'm going to take the mason jar and I'm going to tip it to its side and watch what happens. Notice water comes out, but when I turn it vertical again, it stops. The reason for it is because when I turn it to its side, air pressure breaks the surface tension. What you're not seeing is the mason jar actually has a mesh. And this is what you can use for a screen door. And the water forms a thin membrane along the pores of this mesh. And so long as you don't disrupt that membrane, it'll basically keep the water inside. But as soon as you make an imbalance in the air pressure and disrupt the membrane, you can see the water floats out. So that is the trick to the surface tension mason jar.